Hello there. Today, on behalf of a wonderful team, I will be presenting the project they have been working on for the past months. Curious? Then get a cup of coffee, relax and enjoy the presentation. Imagine, at the end of a long working day, you are getting back home. As soon as you are stepping outside of your office, you start shivering from the cold. Luckily, you have an internet-connected thermostat, which you can turn on before you arrive, making your house nice and warm. A few weeks later you're on a holiday trip. After you have finally found your seat on the plane, you are starting to get a little anxious. Did you turn off the lights back home? When the plane lands, you check your internet-connected lights. You had turned them off. Now you can continue to enjoy your anxious-free holiday. These are just a couple of use cases for IoT devices. However, the world keeps getting smarter and more interconnected as the number of devices with internet access keeps increasing. Along with that, the need to connect to these devices and control them remotely and uniformly in a simple manner is also rising. We introduce ThingsBoard, an all-in-one platform for your IoT devices. With ThingsBoard you can view the state of your sensors and toggle your switches all at the ease of one site. Several challenges lies in front of an IoT platform. First, people want to be able to continuously scale up, vertically, the number of used devices, and, horizontally, the technically supported devices. To handle these requirements the platform should be highly customizable, extensible, and API versatile. Second, safety is another concern. The connection between devices or nodes should be reliable and robust. It would be unacceptable if the whole system would fail due to a small local failure in one connected device. Third, to optimize the control operations, it should be possible to track and control entities in real time. And finally, security is an important concern. It is unacceptable to have unwanted third parties monitoring, or worse, be in control of the connected devices. To ensure the compliance of ThingsBoard with all the challenges and requirements, several capabilities are incorporated into the platform. The main capabilities of ThingsBoard are telemetry data collection, multi-tenancy, data visualization, horizontal scalability, IoT, rule engine and fault tolerance. These capabilities are integrated into the rule chains, and we will discuss them in more detail in the coming slides. To start with, let's discuss the two levels of users that we could distinguish in the ThingsBoard platform. These users are the companies and their customers. Companies create the end users' dashboards and provide access to these dashboards for their customer. Therefore, the companies are able to configure the servers, the databases, message processing rules, dashboard, dependencies, etc. On the other hand, the end users or the customers are able to interact with the created dashboards, in order to handle the real-time data of their IoT devices. So, customers mainly interact with the web UI. The number of customers interacting with the web UI is arbitrary and dependent on the use case. With this approach, the ThingsBoard platform could be applied in different industries such as smart metering, smart energy, smart farming, fleet tracking, etc. This is an example of a client's fleet tracking dashboard. The dashboard consists of multiple graphs which clearly show real-time data of the driving buses. Furthermore, the smart dashboard allows the user to zoom in and make use of the advanced tooltips. As you could imagine, ThingsBoard is quite a complex platform. To understand it, we should have a look into its architecture. ThingsBoard is built following a layered service-oriented architecture. A typical layered architecture contains the presentation, business, persistence, and database layers. These layers could be traced in the ThingsBoard application according to the web UI, rule engine, core, and database layers. Let us take a closer look at the architecture of ThingsBoard by looking at the containers describing the architecture. The containers with a white background are out of scope, as they are not controlled by ThingsBoard directly. The containers with a blue background represent the ThingsBoard containers which are decoupled and deployed separately. From the architecture, we could distinguish four main containers: the web UI container, the transports container, the rule engine container, and the core container. Each of these containers has its own purpose and functionalities. The web UI is the container where the end user interacts with the system. This is a two-way street. The user uses the interface to extract data and gain insights into the connected devices. On the other hand, the user can feed new data or commands into the system. Further, the transport is the container that forms the bridge between physical IoT devices and the network, with the internal state of the application. This container can be strictly divided into separate components, one for each supported transport API. In the same order of ideas, transport container is easily extensible to support more APIs. Next, the rule engine container represents the user-defined logic. It allows to filter, enrich and transform incoming messages originated from IoT devices. Here users can define different behaviors according to the received messages. Additionally, via the rule engine container users are able to connect to external services. And lastly, the core is the bridge container, responsible for REST API calls, WebSocket subscriptions, attribute changes, and monitoring device connectivity states. Now I think you're wondering how such a complex application is maintained, and how the quality assurance process is ensured. To answer these questions we should take a look at the past and future releases of the application. Starting with the first release. The hotspot components of ThingsBoard included the Docker files, databases, telemetry handlers, user interface and transport layer. It is clear that back in the first release ThingsBoard was a very new application. Most of the changed files had to do with the development of APIs, connectors and deployments. Not a lot of efforts were focused on the business logic. ThingsBoard was establishing the base of the application, which they can extend later. With the second release, ThingsBoard has grown quite a lot. It also gained popularity and traction in the community. All the changes in this release had to do with scaling up. The main characteristics of the second release are the structural changes and the refactoring of controller classes and files. The hotspot components of the second release are locale files for the UI, the core controller, actor components, rule engine nodes and chain. Once the dust had settled on the upscaling processes, ThingsBoard moved on to do some quality control in the third release. The main changes with the third release are significant updates of the UI, migration of the database to the PostgreSQL framework, authentication methods going through fine-tuning, and more improvements in various processes. These were the past and current evolution of ThingsBoard. For future perspectives, ThingsBoard is planning to work on three aspects of the application. 1. Improve scalability and robustness. 2. Direct the development towards the edge gateways. And 3. Ease the development process by implementing Python and JavaScript gateway SDKs. Now, to evaluate these perspectives according to the current code quality, we conducted an analysis, both on the application code base and CI processes. The code base contains some tests for the back-end code, but does not contain any useful end-to-end tests. In total, the last succeeding CI builds, on the master branch, contains 603 tests, covering 75% of the classes, 44.6% of the methods, or 46.1% of the lines. A full run of all the tests takes 34 minutes, resulting in developers not being very likely to run the tests themselves. A factor that certainly is influencing the quality and maintainability of code is the rate at which this code evolves, or changes. Taking an example of the most changed component, we could evaluate the code quality based on several measures. In our case, ThingsBoard Server Controller is the most changed component. We took 6 evaluation measures: readability, singularity, complexity, length, abstraction, and tests. Starting with the first one, readability. Standardized and clear naming conventions are used throughout the codebase. The code seems organized and well isolated, there is no duplication. However, the code has no comments, and nor JavaDoc. We recommend adding the JavaDoc to increase readability and support automated documentation. Second, in terms of singularity, by far the most methods have a single responsibility. However, the larger classes could have been split up into more subclasses. We suggest constructing guidelines on maximum file sizes. The third measure is complexity. Many methods are short, simple, and have a cyclomatic complexity of less than 4. Although there are a few longer methods with a cyclomatic complexity higher than 8. We would recommend to use automated code checkers to warn against complex methods. Fourth, length. Most methods are less than 15 lines of code. However, some classes have 60 lines, others 450 lines. Furthermore, there are still a few methods with more than 40 lines of code. We suggest using guidelines to enforce consistency. Fifth, abstraction. All 17 controllers in the package extend from the same abstract base controller class. This follows a logical implementation of abstraction, thus, we don't have any recommendations in this regard. And the last 6th measure, tests. All controllers have a corresponding test suite with at least one test. However, some classes are tested thoroughly, others hardly. The test code itself is often lengthy and complex. We would suggest to enforce a minimum test coverage, and use reviews to verify test presence and quality. To summarize, ThingsBoard still has some room for improvements. This could be achieved in the following releases. Although it is evident that ThingsBoard is an awesome platform that offers a lot of perspectives for IoT development. That's the end, folks. Hope you enjoyed the presentation. And yes, cheers.